there's this thing that we do, and I'm pretty sure we all do it, where you realize that this bit of code and that bit of code are basically doing the same thing, except they're implemented differently, and so you decide to switch everything over and use just one of them. And about 17 tests break, and you remember that there's this one edge case, and so you quickly patch a conditional, and now 24 tests are failing, and you realize that there's a missing dependency, and you pull that in, and now you have about 50 failing tests, and it turns out that there's a conflict between two of the dependencies, and so you swap them around so that they load in the opposite order, and now almost 80 tests are failing. And by the way, that encoding thing seems to have gone haywire again, you know, where it's assuming that it's getting UTF-8, but actually it's getting Latin 1, or is it the reverse? I don't know. And the method you're trying to use needs to access some stuff that's not a part of the public API, and so fuck it, you use send. And the whole bunch of stuff blows up, and it's something to do with unexpected nils, and it's been hours since the tests were last passing, and now you're considering monkey patching nil class. And instead, you do a git reset hard. The most difficult part of refactoring isn't actually making the change. It's knowing where to begin and what to do next, and figuring out how to make that change safely. So I'm going to use the children's song that goes, "I know an old lady who swallowed a fly," as an excuse to talk about decision-making in refactoring. Now, the song is incredibly simple, but it has an algorithmic component. And so this gives it enough complexity so that we can talk about real-world refactoring principles without bogging you down in real-world code. The entire example is all just text. It's hard-coded into a here doc, it's wrapped in a method, and wrapped in a class. And the very first thing you need to ask yourself when you're about to refactor is whether or not you should do it at all. And in this case, frankly, the answer is no. The song hasn't changed in generations. The code could be appalling, and it doesn't matter. The code works. We're never going to touch it again. Put it in production and walk away. And so this refactoring is going to be completely spurious, which under normal circumstances I would advise against. Now, once you've decided to refactor, the next question is, do you have tests? And again, here, the answer is no, because why on earth would you test a hard-coded string? So before we start refactoring, I'm going to copy the string into a test and make sure that the code still works once we start changing things. And so once you have a passing test, the next step is to just look at the code for a bit. Notice stuff. See what jumps out at you. Look for things in the code that you don't like, and then pick one thing. I tend to pick either the thing that I hate the most or the thing that I understand the best. And what most people remark on here is all of the duplication in the strings. There's duplication between verses, there's duplication within verses, and of course it's not exact duplication. The bits that change are all embedded in the things that stay the same. And also it's stuck in this great big here doc, which makes it hard to deal with a small piece at a time. The first change I'm going to make is to introduce a little bit of indirection. I need to be able to handle each individual verse separately. And for this, I'm going to use a case statement with one branch for each verse. And this means we have to loop over the range of verses and join them to get the full lyrics. And you can do it all in the same method, but we only really care about the case statement. And so I'm going to go one step further and isolate it into its own method. And finally, we can start touching individual strings. And what I want to do is tease apart the bits that vary from the bits that stay the same. In other words, some of this is template, and some of this is data. And we immediately run into the problem of naming things. Typically, you extract it, you name it. If you get the names wrong, it can make the code dramatically harder to understand. And code that's harder to understand is harder to change. The easiest time to get the names wrong is right now, at the beginning of a refactoring, when you understand the least. And of course, even if you get the names right, it doesn't really fix the problem of having everything mixed together. And so when dealing with this sort of thing, I like to use the C-style string formatting using the % method on string. It provides a clear separation between the static part and the variations. I like that it doesn't matter where in the string the placeholder is. All of the data ends up outside of the template, and I haven't had to name anything. Now, if you apply this to each of the verses, the duplication between verses has gone from being similar to being identical, and all of the bits that vary are off to the side. And it's the same for the duplication within the verses. Each entire verse now has all the template-y stuff on the left and all the data on the right. It's a tiny change, but it's noticeable even when squinting at it. This is what we started off with, and now we have this. Now, you might argue that I just shoved code around on the slide and pretended that I've refactored, like some people shove code around on their plate, food around on their plate, and pretend that they've eaten. And it seems kind of pointless. But some people can look at duplication and see what methods and objects to extract, and I can't do that, usually, not at first. I dissect it in place to get more information. In this code, separating the template from the data has made the algorithmic part a lot more obvious. Each verse grows systematically. It adds repetitions and then stops abruptly. Now, most of the verses take this phrase and then repeat it some number of times, passing in a variety of different creatures. And this little bit of code seemed like a complete thought. For the first time in this refactoring, I want to name something. There are 3 common strategies for naming things, and 2 of them are kind of shitty. The first is to name it by using some fragment of the implementation, like swallow, or to catch, something equally concrete. And this is the kind of name that quickly gets out of date. You find yourself with a method named blue, it returns the hex code for red. The second strategy is to name it structurally. So this is a recurring line, or it's an incremental sentence, or it's the middle phrase. And this is the kind of name that is technically correct, but perfectly unhelpful. The problem domain isn't really about phrases at all. It's about a little old lady who inexplicably swallows a fly and then compounds the problem by swallowing larger and larger creatures. This particular part of the song is trying to explain the reasoning behind her behavior. It's trying to explain why she would ever do such a thing as swallow a bird or a dog or a goat. In other words, her motivation. We need to call motivation some number of times, each time with different data, and ignoring for a moment that cows and goats are vegan, the predator in one verse becomes the prey in the next. And what we really want is a single list so that we're not writing everything twice. Now, Ruby has an enumerable method that conveniently yields each consecutive pair. Given a list of critters, loop over them, pass each pair to the motivation method, join it into a single string. This chunk of code also seems like a complete thought. I'd like to name it. And here, we're talking about the sequence or chain of events. We're describing some sort of bizarre food chain. So 2 things just happened. We identified and extracted the algorithmic piece, and we named it. One thing explicitly did not happen. We didn't use the new code anywhere. And technically, this is called a parallel implementation. But in reality, it just means I wasn't sure what I was doing, and I wanted to figure it out separately without breaking the code. So after you make up a new implementation in parallel, you should be able to swap it in, and it should just work. Or not, like here. Sometimes it fails. This means that there's something that you haven't understood yet. So here, one part of the chain is not like the rest. What you'll see in most code bases when you have a rule with an exception is a conditional. These are kind of problematic in a foot in the door kind of way. You have a conditional, you blink, now you have 12 conditionals. Eventually, somebody is going to get hurt. But within the context of a refactoring, conditionals can actually be a very useful transitory tool. It's 2 steps. First, you create the conditional, then you name what it represents. And this will give you more information so you can make better decisions about what to do next. The conditional itself should contain the smallest possible difference. And this makes sense. If you have the same thing in the if and the else, then it's not really conditional on anything. And so that gives us the wriggly bit of the spider. But there's nothing to put in the else branch. And you could drop it, but that might lead you to try to name just the exception. And you're not. The conditional doesn't represent the exception to a rule. It represents two variations on the same idea. It's not two different things, it's one idea, and that idea is what you have to name. And in the song, we're talking about the critter's distinctive features or some sort of qualifier. And it's just that some critters aren't all that distinctive or special. And so if you had left only the bit about the spider, then you would probably end up naming it in terms of the spider, and it would make your refactoring much more difficult. The method needs to take an argument. Prey is about hunting. This is not about one animal killing another for food. It's about the critter itself. And finally, here's the payoff. Notice how the method has completely isolated this conditional. Notice that the result of this method relies entirely on the argument that you pass in. The method could live anywhere. It could be a global function for all we care. It doesn't depend on anything to do with the song class. In other words, we have this critter string, and we're trying to decorate it with more behavior. And instead of passing the critter to the qualifier method, we should invert it and send the qualifier message to the critter. And to do that, critter has to be an object. The data can all be extracted from the verse, new up all the critters, give it a little handy method to get just the ones we need for whatever verse we're on. And now predator and prey are no longer just strings. They're objects to which we can send messages. And this chunk sticks out a little bit. Seems dirty, but it's not really. It's just in the wrong place. It belongs inside the critter, which means we have to name it. And then finally, we can slip the chain into the case statement in verse without causing a single test to fail, our only test, by the way. So there's this abstraction. It wasn't at all obvious at the start, but it was there. It was just buried. And focusing on the differences isolated meaningful ideas. All of these ideas ended up building this tiny object, this critter. All of this time, we've been focusing on differences. Similarities, we started out with fragments of plausible duplication all throughout the song. Now there are whole chunks of unmistakable duplication. Even the data has gone from being mostly a jumble to having a recognizable pattern. It's tempting to focus on the sameness, to extract it, to name it. Resist that temptation for as long as you can. Identify the smallest difference and see if you can make it go away. And then ignore it and look at the remaining differences. The first one here is easy. It's the critter's name. And when we get that fixed, it only leaves one difference. The critter object needs to be a little bit smarter, and we're stuck trying to name this concept. It's a little bit like commentary or maybe an aside. And we'll need to pass more data when creating critters and then use the abstraction. And now this is identical, and we can ignore it. Take a moment to squint at it. Notice that the red stuff is strings, the black stuff is stuff we've named. The template is exactly the same in each verse, and it's all red. And the data is exactly the same in each verse, and it's almost all black. Almost. The asymmetry sticks out. It's the aside for the fly, and if you have an abstraction for something, you should use it. And now something interesting has happened. All of that sameness that we've been ignoring can now mostly go away. Sameness is a trap. It's a distraction. Differences are the parts that are interesting because they're fragments of a bigger idea. Once you've named the larger idea, the sameness either evaporates or condenses into something obvious. So this all started with identifying duplication as being the ugliest, the most obvious, the best understood problem. We encapsulated the algorithmic portion of the song, discovered and extracted the critter, and now most of the duplication has collapsed. We need to look at what's left. The song class is shorter than it was, but it's doing a lot more stuff. There are 4 methods in there. 3 of them are private. All 3 of those are about the verse. And there's also still some duplication left in that case statement. It's here and here. All the private versey stuff seems like it could be its own thing. Verse depends on I. We should pass it in to the initialize method, expose a reader for it. And a class named verse shouldn't have a method named verse. This would be better as 2s. Finally, we can swap out the call to the old verse method with the parallel implementation, and then delete the old implementation. I'm not saying that you should always split things up into new methods and classes, but it can be useful to ask yourself, if this were 2 things, what would they be? If you can come up with a plausible answer, something that's not too far-fetched, then it might be worth exploring that. And just be ready to inline it back if you don't like it. And in this case, it turns out that encapsulating the verse makes it ridiculously easy to fix the rest of the duplication issues. The last I critters can be assigned to an instance variable given a reader. Same goes for the first of the last. And as before, the duplication draws the I, ignore it. Instead, find the smallest difference, isolate that somewhere, name it. In the context of this, of the song, this is everything that happens after the little old lady swallows the critter. Right? It's the aftermath of the incident that kicked off the whole chain of events. And if this is the aftermath, then the first bit is the incident. And now 2s tells a story with all of the details relegated to private methods. And lastly, now that we have a critters method on the instance, we don't have to pass it around as an argument. We can just rely on the reader. Verse is pretty decent. 2s relies on incident and aftermath in turn relies on the chain stuff. So this is pretty good. I have one complaint left about this, and it's that case statement. I just added it at the beginning just to get the refactoring started. I thought it was going to be temporary, and now it's still hanging around. That's kind of annoying. And so the final refactoring is one of the classics from Martin Fowler's book called Replace Conditional with Polymorphism. It's a step-by-step recipe. Refactoring is not about reaching maximum design pattern density. It's about balancing simplicity, readability, and changeability. And it can sometimes feel like a bit of a dark art. And it kind of is, in the sense that there's a bit of gut feeling involved in recognizing the stuff you don't like. But that gut feeling, that intuition, is learned. Read about code smells. Look at code. Do code reviews. Practice refactorings. Try things and then back them out. Try something else. It should feel like you're discovering abstractions, not inventing them. A good abstraction feels obvious in hindsight. It was already there. You just needed to clear away some of the noise around it. Don't name the noise. Don't name the fragments and slivers and shards of ideas. Name the whole concepts. This clearing away is a controlled and systematic process. It's meticulous. It means taking safe steps. And safe steps don't break your test suite. Notice how different this is from TDD. In TDD, a failing test is a precondition. You make it stop failing by moving forward. In refactoring, a failing test is feedback that you did something wrong. You fix it by backing out that change, trying something else. Safe steps are deliberate. They're careful. They're small. And when I say small, I mean much, much smaller than you'd probably be used to. I'd encourage you to make your steps so small that if you get a failing test, you can get back to a green test suite with one single undo. And I'm not saying take steps this small always, not forever, but do it long enough to get an intuitive understanding of how to make changes safely. And I promise you that you will never again git reset hard away hours of your life. Thank you.